This lesson is for Advanced Algebra, Lesson 11.5 on the rational zero theorem. A reminder to students that the word rational is another word for fraction. So we're going to be looking for fractions as zeros today. In the previous lesson, we talked about some different methods you can use to find zeros or roots or solutions. So let's review what those are. One of the ways you can find a root is to graph it. And when you do the graph, you're looking for x-intercepts. The x-intercepts are the roots or the zeros. You can also use the quadratic formula, which we'll get to later on in Chapter 11. You can also factor. After you've factored the polynomial, then you set the factors equal to 0, and then solve. We're going to focus today in this lesson on using the rational zero theorem and then verifying by graphing. So factoring is not our task today, but factoring should still be something that you remember how to do. Once you've found the zeros, you may be asked to classify them first as either being real or non-real. The real ones are the ones that you can see on a graph. The non-real ones you can't see because they are imaginary, meaning they actually have the letter I. Remember that the letter I is the same as saying the square root of 1. The square root of -1. So the imaginary ones you won't be able to see. You'll just have to say how many of those there are. The ones that you can see, you need to factor, or you need to determine further how to classify them. The real ones that you can see can be classified further as being either rational or irrational. The rational ones are fractions, or can be written in fraction form. The irrational ones cannot be written in fraction form. So the most famous irrational numbers are the number pi and square root of 2. Neither one of those can be written as a fraction. So let's learn what the actual rational zero theorem is. The rational zero theorem identifies a list of possible rational zeros. So this method doesn't give you your answer on the first try, it just gives you some possibilities, and then you have to do more things after that. The way that you make the list of possible zeros is you take the factors from the constant term, which is always the last term in your polynomial that doesn't have a variable next to it, and you divide that by all the factors of the leading coefficient. Students should know where the leading coefficient is. It's got to be the first term in the polynomial after it's been put into standard form. Then you're going to check the list by either calculating or graphing or both. So let's try this now with an actual example. Find all the rational roots for 3x cubed plus 2x squared plus 3x plus 2. Notice that it doesn't tell you what method to use, but the appearance of the word rational is a big hint. As soon as it asks you to find the rational roots, that's your hint that you're going to use the method that we're doing in this video. So let's review again what pieces you need. You need the constant term and you need the leading coefficient. The constant term is the number that's at the end without any variables, and the leading coefficient is the number that's at the front. Now remember, we need the factors of both of those. So we're going to do the factors of 2 on the top and the factors of 3 on the bottom. So the factors of 2, since it's prime, are just the numbers 2 and 1. Usually for the top number, I like to go in descending order. On the bottom, I like to go in ascending order. 3 is also prime, so it only has 2 factors, 1 and 3. Now when I go ahead and I make my list, I gather all of the factors on the top and combine them with all the factors on the bottom, keeping in mind that you have to put a plus minus in front of each factor. So my first factor, I'm going to start with the 2, and I'm going to put 2 over 1, which is just 2, and then 2 over 3, which is 2/3. So now the 2 is finished. The 2 has been put with both of the factors on the bottom. Now I'm going to take the other factor, the 1, and I'm going to put it with both of the numbers on the bottom. So I say positive and negative 1 over 1, which is 1, and positive and negative 1/3. And so those are all my factors. Keep in mind, are all my possible factors, or all my possible roots. Keep in mind that there are actually 8 of them. There's 4 listed, but there's positive and negative for each one, so there's really 8 altogether. So what we would need to do next is figure out which of these possibilities actually generate a 0 in the polynomial. So we would have to take the original polynomial, which I'm just going to recopy right now real quickly. And wherever there's a variable, I'd have to plug in one of those values. For example, the number 2. So I would take 3 times 2 to the third plus 2 times 2 squared plus 3 times 2 plus 2, and I'd see if I get a 0. And if I do, then I know that that 2 is one of the zeros. But if we use that method now, we would have to try all 8 numbers. So we'd have to try it again with a negative 2 for x. Then we'd have to try it again with a positive 2/3 for x. And I really don't want to waste my time checking all 8 of the possibilities. So what we're going to do next is graph it. So take the original polynomial without the 0 part, type it in on your graphing calculator, and see what the graph looks like. I've already done that. And so it looks like this. Take the time to actually do it on yours because you'll need to find the 0 with me, and I want you to have that available. So type in your equation, hit graph, and now we need to identify where the 0 is. Now before we do that, I just want to clarify one thing. We can see a 0 exists right here. So there's 1. So I know that I'm going to have one real 0. Because of the degree, I'm expecting that there will be 3 zeros altogether. So there's one real 0, that means there's going to be 2 non-real zeros. So now I need to go further and figure out something else about the real 0. Is it rational or irrational? And to do that, I want to actually find where it is on my graph. And so what you do is you go to Menu, Analyze Graph, and you choose 0. It's going to ask you for the lower bound. Basically what they mean there is go to the left of where the 0 is and tap with your center button. Then they ask you for the upper bound. So you go somewhere to the right and you tap again, and it tells you where the 0 exists. And so the number that we got is negative 0.667. So let's consult our list and see if we think that that number is in the list anywhere. Negative 0.667 is about the same as negative 2/3, because negative 2/3 is negative 0.6 repeating. So I want to verify if that is where the 0 is. Rather than trying out all 8, now I've narrowed it down to a negative decimal. And the only negative decimal I'm going to have here is either negative 1/3 or negative 2/3. And negative 2/3 is closer to negative 0.667, so that's the one I'm going to test out. So now go to a regular calculator page, and you're going to type in the polynomial, and wherever you see an x, you're going to type in negative 2/3. And we're going to do that to see if a 0 is generated. So here I've got it all typed in. I hit enter, and I did indeed get the number 0. I'm just going to go back and verify that it looks the way I think it should. And so since it did generate the number 0, I know that negative 2/3 is my 0. So I'm going to say I have one real 0, and that real 0 is also rational, and that rational 0 is negative 2/3. So I have one real and rational 0, and I have 2 non-reals that you don't need to find. You just need to identify how many of them there are. So that's the basic structure of how you'll use the rational 0 theorem to find zeros. Let's try one more. So here's our polynomial, and the directions would again be find all the rational zeros for this polynomial. So the first thing we're going to do is make the list, and I need the constant term and the leading coefficient to do it. Numbers for the constant term on the top, numbers or factors for the leading coefficient on the bottom. So let's start with 21. 1 and 21, 3 and 7. Those are the factors of 21. I'll put them in another order later. Now let's go with 6. 1 and 6, 2 and 3. Again, to make your list a little bit easier to deal with, I like to do the top numbers in descending order, the bottom numbers in ascending order. But that's just more of an organizational piece. It's not really part of the actual method. So I'm going to say 21, 7, 3, and 1. And then on the bottom, I'm going to say 1, 2, 3, 6. Now I'm going to go ahead and start assembling the actual list. Remember that we're going to take all the numbers on the top and pair them with all the numbers on the bottom. So I'm going to start with the number 21. Put a plus minus in front. We're going to say 21 over 1, which is just 21. Then I do 21 over 2. 21 over 3, which is the number 7. And then 21 over 6 And let's reduce that. 21 over 6 can reduce to, they have a common factor of 3, so that reduces to 7/3 actually. So 21 is done. Now let's move on to the 7. 7 over 1 I already have. 7 over 2 I don't have, so I'm going to put that one next. 7 over 3 I've already got. 7 over 6 I don't have, so I'm going to put that one down next. 7 is finished. Now I'm going to do 3 with 1, which is just 3. 3 over 2, which I don't have yet. 3 over 3, which is a 1. 3 divided by 3 is 1, so I'm going to put that down. And 3 over 6, which is a half. So the 3 is finished. And now let's do the 1. 1 with 1 I already have. 1 with 2 I already have. 1 with 3 I don't have yet, so let's put that one down. And then 1 with 6. So now that's a lot of possibilities, isn't it? If we had to check all of them by hand, it would take us an awful long time. So what we're going to do next is graph it and find the zeros on the graph. So I went ahead and I graphed the formula, graphed the polynomial, and I got a graph, and I went through and I did that same command that I did before to find all the zeros. So just a quick review on the commands you need to find all 4 of the zeros. You'd have to do it 4 times. You'll do menu, analyze graph, and then you'll click to the left and to the right. Then you'll do it again, click to the left and to the right. Menu, analyze graph, click to the left and to the right, and then the same thing for the last one. So you can see here what we got. Now this one looks a little funny because we've got a negative 5.8 times 10 to the negative 11. What that really means is a really small decimal. So when the calculator was trying to identify where this 0 occurred, it wasn't able to get it exactly on the x-axis, but it got it pretty close. So this is really the point, negative 2.3 comma 0. The rest of them have a 0 for the y value, but this one didn't really turn out that way, so it was a little bit of an estimate. So let's write down what we got for our zeros, and then we'll verify those. So we got negative 2.33, negative 0.5, 1, and 3. So let's write all those down. Negative 2.33, negative 0.5, 1, and 3. So I want to see if those are anywhere in my list. Well, 2.33, that might be a fraction or a mixed number. So that could potentially be like negative 2 1/3, because that would be the same as 0.3 repeating. And negative 2 1/3 is the same as negative 7/3. 3 times 2 is 6, plus 1 is 7. So I want to see if negative 7/3 is in the list. And indeed it is. It's right there. So I'm going to test that one out in just a minute and see if that one generates a 0. Now I'm going to try to find negative half, which is right here. So I'm going to test that one out. I'm going to try positive 1 and positive 3. So I don't know yet if those are my zeros, but I need to verify them. So I'm going to calculate for all of those. So you're going to type in 6, and then your first 0, so like negative 7/3, to the 4th, minus 7 times your next 0. If we're trying out negative 7/3, that would go in the parentheses still. So you'd try negative 7/3 in all those empty spots, and you'd see if it generates a 0. So then you're going to do that 3 more times. You don't have to retype it each time. You can highlight and copy and paste on your calculator and just change whatever the 0 is to the next number. And what you'll find here is that all 4 of them do indeed generate a 0, so all 4 of them work. Also, I want to point out that you could see all 4 of them. They were showing up as zeros or x-intercepts on the graph, so that means those are all real zeros. So I'm going to list them out. Negative 7/3, positive 3, positive 1, and negative 1/2. Those are my 4 real and rational, because they came from the list, zeros. And I would expect that there were 4 because the degree of the polynomial was 4. So I didn't show all the steps here. That was a calculator part that you would have had to do on your own. You'd type in the formula, you'd type in each of the zeros, so you'd have to calculate 4 separate times. In each case, they all generate a 0, so they're all rational.